All right, everyone, settling down. Thank you. So just to start off, in recognition of Aboriginal and Torres Strait Islanders peoples' spiritual connection to country and in continuing ACU's commitment to reconciliation, it is customary to acknowledge country as we pass through. Today, we acknowledge and pay our respects to the First Peoples, to traditional custodians of the lands and waterways. We thank them for the continued custodianship on this campus, which is Camaragal land, and on all campuses of ACU. We thank them for their continued custodianship. We acknowledge and celebrate the continuation of a living culture that has a unique role in this region. We also acknowledge elders past and present and thank them for the wisdom and guidance as we walk in their footsteps. Now I'd like to hand over to Dr. Sharon Sanders to introduce our brown bag today.
So I've already introduced him to everyone in the room, but for the benefit of those online, so Associate Professor Sam Liu is joining us from British Columbia in Canada, from the University of Victoria. Sam does some really exciting work in e-health and m-health interventions, so online delivered interventions, and particularly in the area of things like just-in-time interventions and things like that. He's going to show us some really cool technology that he uses to do that. And he also does some work in terms of using that technology to do measurement as well, such as monetary sampling. So I think this is going to be really relevant for those of us who do online interventions, especially for teachers, because, yeah, it's going to be really quite nicely. So, floor's all yours, Sam.
Great. Thank you so much. It's so nice to be here and away from the cold in Canada. So just to, I guess, put in kind of perspective where I'm from, though for those of you who haven't been to Canada, I'm on the west coast of Canada. So this is Vancouver, and then University of Victoria is right on the island. So technically, we're the most southern point of Canada, or the warmest spot, I would say, in Canada, which is really nice. For those of you who have been to Victoria, so this is our university on the top, your right or your left. And then this is our famous Inner Harbor, which is where all the government building is. And if we do get to go, I recommend that we have this like hot tub boat going on right now. So you get to putter around the Inner Harbor, and then you have this hot tub, and then there's a stove and wood. You just like, you know, put that in. You can bring your drinks. So much fun, and it runs year round. So highly recommend that in the harbor. This is my team. I just want to acknowledge the hard work that my team is doing and some of the research fundings that we received in the past. So my research focuses on two main areas. So one is designing and evaluating online or smartphone-based programs. And so from a design perspective, we also build both the infrastructure, so technical infrastructure, to allow researchers to create these programs, but also we design the content as well. So I guess in a way that we're kind of vertically integrated in a way. And my second area of research is mostly focused on big data analytics. So we take social media data from users' generated social media data or wearable data, and then we try to then predict person's outcome. So an example of that research is we would mine Twitter's data in the past, and then for the entire country, and then we'll overlay that with physical activity data, and then depending on what people are saying online, we can do top modeling, sentiment analysis to kind of figure out, engage with what the overall physical activity level is. So that's my second area. But today I'm mainly going to focus on my first area of research, is designing and evaluating smartphone-based interventions. So because it's a pretty small group, I feel like if you have any questions, just put up your hand. And for those of you online, please do the same as well. If you can just point it out as well. So the first part of my talk, I will talk about how we actually developed and evaluated this family-based physical activity intervention. I know most of you are school-based researchers and delivered intervention in school, but the use case I will provide, maybe there's some parallel that you can find. So we are helping families to be more physically active using this adaptive intervention. And then second is I will talk about the tools we actually use to develop it. So I think no doubt we all know physical activity is great. So this is why for the intervention that we're developing is aimed for cancer prevention. So it's a primary cancer prevention study. So we're trying to get the parents and catch the kids very early on so they can be physically active to hopefully prevent cancer. So you might ask, why are we using mobile phones? Or what is exactly mHealth? So mHealth in general, the term is the delivering of interventions or collect data using your smartphones. And then why we would use it? Well, there are two main reasons. One is there are excellent data collection tools. And then second is they can really deliver scalable interventions. So even though they are, you may think of them as separate, but they are really working in conjunction with each other, because in order to deliver really personalized intervention, you need to be really good at collecting relevant data, right? So we kind of work on both. Why is this so good at collecting data? Well, because you can collect in real time. That's one thing. And then with EMA studies, some of you might actually know EMA studies, so ecological momentary assessment studies. These type of studies allow you to assess the individuals multiple times throughout the day, instead of, let's say, only at baseline or 10 weeks from now. And one advantage of assessing them multiple times throughout the day is that you can actually really plot out within-person changes, and then to see perhaps when a stressor comes, what would happen afterwards. And then one of the other great things, you can overlay that data, survey data, with passive sensing data as well. So your weather data, for example, or your wearable data, or link it to other types of EMRs or electronic medical records. So we would use, so EMA, I see it as a pipeline. So usually for when we developing adaptive or smart interventions, we would do kind of EMA studies first to figure out what variables we can tailor. And then we take that information and then we actually deliver a just-in-time adaptive intervention. So that's kind of the pipeline we go through. But sometimes you can also kind of, if you already know what variables you can tailor based on previous literature, then you can also jump right into just-in-time adaptive interventions. So the current evidence surrounding kind of mobile health intervention for physical activity in general is that overall, there's a small to moderate effect size in terms of improving physical activity. What we find is that if the individuals are at a high risk for some type of illness, then effect sizes, physical activity seems to be a little bit higher. And then some of the BCTs, so BCTs are behavior change techniques. So these behavior change techniques include goal setting, self-monitoring, feedbacks, or instruction how to perform the interventions. But even though we kind of look at this kind of force block here, we can see that the effectiveness of the intervention varies quite a bit, right? So it really depends on how do we design these interventions. So a lot of researchers are trying to figure out what type of clusters of BCTs we should use, or how do we better tailor the intervention themselves. So this is where the just-in-time adaptive intervention comes in. So short term of that is JEDI. So it's very like Smart Wars, like, you know. So we always have a fun time with the play on the words. So the just-in-time adaptive intervention, the whole idea is the intervention will adapt to you at the right time and deliver the right content to you. So overall, the field is relatively new for several reasons. One is we're still trying to figure out what is the best tailoring variable. And then the second is trying to figure out from the technology side, how do we deliver it in a way that's very seamless with our day-to-day lifestyle. So what we have found so far from meta-analysis is that these JEDIs usually have a larger effect size than non-JEDI studies. And it's usually acceptable. The study has been done, and intervention usually lasts between 3 to 4 weeks in length. And most of the studies right now are fairly in a feasibility trial, so they haven't gone into the effectiveness or kind of the scale up. And then the challenges associated with it really, if you read kind of the barriers for both researchers as well as participants, is kind of the technology aspect, and then how timely it is, because sometimes when the phones shut off, you may not necessarily get them just in time. So there are some technical barriers associated with this. So you may ask, how does exactly JEDI, like how does it work? So this is kind of a diagram that shows how it works. So first you need to figure out what are the different tailoring variables. So there are sensor-based variables. So this could be your smartphone watches, it could be GPS data, depending on how you want to design the study. And then there's also participant input. So these could be questionnaires. You may ask participants about their motivation level or when they will like to do exercise, for example. And then provider input. So this could be like teachers input or your healthcare providers input, or external databases. That's like your electronic medical record or some type of third-party databases. So these are the tailoring variables. Then researchers can then make their own decision rules. So there are various different ways of making decision rules. The simplest way is just a tree. So if this happens, then this happens. And then you can obviously make it a little bit more complex with some kind of machine learning, AI. I feel like that's the hot topic these days. And then based on these decision rules, then you would change, you would then pick out what the intervention option is going to be. And then that will hopefully change the outcome. So proximal outcome could be change your motivation level. And then distal outcome could be changing your actual behavior, right? So these are kind of, and then it goes back in a loop like that. Okay, so going back to our study, so we want to design a family-based physical activity intervention for kids that are age 12. The reason we're developing it for this particular age group is that they're more susceptible to change in terms of behavior. And then for the adults in this particular intervention, most of the adults in this area, they're most likely on a smartphone. And then we think that this could be one of the interventions that's scalable and tailored to the parents. So the intervention itself, we are changing, we're helping improve child's physical activity by supporting parents or changing parents' behavior. So the study itself is divided in two different phases. So the first phase is a 6 months phase where we worked with participants to co-design the app itself. And then second phase, 8 months, is a feasibility study. So we recruited about 40 participants. We did a simple pre-post. So this grant that we received is from the Canadian Cancer Society. And as you can see, it's a pretty aggressive timeline for designing a mobile intervention. If you haven't worked with any mobile apps, like it's a pretty aggressive timeline for any intervention. And the reason we're able to do this is kind of using the infrastructure network we have built behind the scene. So in phase one, this is actually how we design the app itself. So you can see what the app will look like. So we have 4 different sessions with the participants. So in the first session, we're trying to determine what the features are. And then we would use our platform, Pathverse, which is a no-code app development platform that we made. And then we're able to then do mock-ups with the participant on the fly. And then we will review the UI. And then finally, in the third session, we will then finalize some of the app functionalities. So as you can see, this is what the UI of the app looks like. So on the bottom here, we have home, and we have a tracker of child's physical activity level. And then we also have goal settings and the forms there. So during this particular phase, we went through kind of several iterations, and then it's really important to have co-design with the participants. The reason being is because sometimes researchers think we have all the answers, but we actually don't. A lot of times we'll redesign, but may not necessarily turn out to be what the participants want. So it's really important to kind of involve them. So we had a pretty diverse population group there. So the app, some of the main features of the app you can see there. So it had goal settings, it had virtual points, it had self-monitoring tools. So these are kind of the features that it's requested by the participants. And then we're kind of able to then integrate that into the app itself. So here is the okay. So we used something called multi-process action control framework to inform how we actually design the intervention. So the MPAC framework. I think it's very similar to a lot of the SDTs or some of the concepts. Have anyone heard about this MPAC framework? Okay, so briefly, you see the pyramid on the left. So the whole idea is that you start on the bottom tier. So the bottom tier is where you start building intention for behavior. And then you move on to the actual behavior itself. So we call that the regulatory. So we're trying to close the intention behavior gap. And then once we move up to the regulatory, where we try to teach about self-regulation skills. And then we will then move to the very top. It becomes reflexive, meaning that the behavior itself becomes automated or becomes part of your identity. So the whole idea is we will start build the intention and then move up to the regulatory and then move up to the whole reflexive processes. So in a typical intervention that we design, it's very linear. We would always present on a weekly basis, like lessons start from the very bottom layer and you kind of move up, right? So that's the very linear. But with a Jedi, we don't want to do that. We want to make it very kind of dynamic. So depending on where the participants is going to be, then we should be able to tailor the content accordingly. So this is what the Jedi looks like. So this is one of the decision trees behind the scene. So there's a lot going on here, but I'll take you through it. So the first thing is that the decision tree is going to figure out what the child's physical activity level is going to be on that day. So we're doing it by two different ways. One is it could be through child's IPPE. The second, we can simply ask the parent to do it. So based on that, yes or no, did you meet the physical activity guideline in Canada for kids? Then we'll figure out if it did, that's great. If it did not, then we'll figure out what is the parent support level. And if the parents have supported on most day of the week, then we give them some kind of suggestions about alternative activities. But if they have not provided enough support, then we figure which of this kind of level they're at. And then if they're on the very bottom reflective level, then we would then introduce content that's related to kind of building up that intention and close the intention behavior gap. So that's kind of how we structure it. So every single week, randomly a survey will come up and we'll prompt the parents and then trying to figure out what is their support level, what is their child's physical activity level. So I'll show you what this will look like in action. So a survey will pop up. So this is obviously survey based. So let's say 3 out of 7 days, and then the survey goes in, and then when the survey goes in, and then a new content is presented to the user themselves. So behind the scenes, like, well, obviously that seems very easy, but I think figuring out the decision trees and actually figure out the content accordingly, and then also write the content in an engaging way is actually can be quite challenging. So we actually behind the scene we made another version of this program using ChatGPT. So we actually asked ChatGPT to generate various versions of certain constructs. So then it becomes a little bit more engaging. I think, at least for me as a researcher, I'm not very good at writing engaging pop culture content. So ChatGPT sometimes they can kind of flip it and help you that way. So we're kind of playing around with if there could be a potential way of generating engaging content. So here are the results. So these are the participants. So 40 families, 46 children in total. So if you look at the child's ethnicity, it represents, we actually got quite a diverse population. It represents kind of the population group that's within BC.
Yeah.
Okay, and then so here are the study outcomes. So we're measuring both the child's behavior, so child's IPPE, that's measured by Fitbit, daily steps, and then also parental support behavior. So we're measuring kind of their affect, attitude of parental support, capabilities, behavior regulations. So here, essentially, so this is on the very top layer, the reflexive, and then these capabilities, behavior regulation, and they're kind of the middle layer, and then affect and attitude are on the bottom layer. So we were looking at, well, what are some of the things that we're changing? So overall results, we found that there was a significant improvement in child's IPPE, steps, and overall parental support. So the effect sizes for PA is small to moderate, and then pretty large for parental support, which aligns up with kind of previous literature as well. And then we also saw an increase in the identity, habit, and regulation. We didn't see a significant change when it comes to affect and attitude. I think the reasons being, like, when people are joining these kind of programs, they probably already know that supporting child is probably important. So that's why we didn't anticipate. If you look at the baseline values, there's definitely a ceiling effect there. And what's really interesting is that when we look at usage data, with this kind of adaptive design, our usage is actually quite high, which is very promising for these mobile-based interventions because engagement is always a challenge there. So here's some of the feedback received, some of the positive and negatives. I'll let you take a moment to read them. But overall, kind of themes positive. They found that content layout useful. Areas of improvement is that they're hoping for more, like, I guess, child-specific apps and so forth. So other types of content just for the child. Yeah. So this brings back kind of, okay, so we designed this JEDI intervention. So I think a lot of researchers are probably interested in kind of using mobile phones in their research, either that's collecting data or deliver some type of intervention or smart intervention. But there are a lot of challenges associated with using mobile technologies. So first is probably the cost and time required. Because as a researcher, a lot of us, we don't know how to code, right? That's another skill set we have to learn. We have to figure out like the UI design, and it's very expensive. If you don't have external grant money, it's very expensive to hire a developer. And if you do have grant money, I don't know about the grant funding in Australia, but in Canada, like, you know, you can't allocate like 90% of the grant just for salaries, and you have no money left over to actually develop, to actually do the research. So there are a lot of issues, and obviously there are like data integration, security, privacy, app maintenance. So all these issues kind of becomes huge barrier for us to design these interventions and collect data to inform these interventions. So the average cost to usually design an app is about 100 to 200K USD. When you come to think about it, it's actually, I mean, when you develop an app, you probably need to hire 2 full-time developers. One handle the back-end database and one handle the front end. So that's like 200K right there, pretty easily. So it's pretty easy to burn through your grant money. So this is kind of where we decided to create a no-code development platform to support JEDI development, to support data collection, to support kind of become a repository for researchers to host their app. So I don't know if you guys already know no-code, like have an idea of what no-code platforms are. No? Okay. Okay, so the whole idea of no-code is that you should be able to design a website or design a survey that's online without software programming. You should be able to use drag and drop. So an example of this, so for data collection, you probably use RedCap, right? Or Qualtrics. Like I think RedCap is great, but I have to say their UI is probably not the best. It's stuck in a certain age, but it works, right? Qualtrics, on the other end, they're great as well, but they have some limitations when it comes to if you want to collect wearable data, so forth, stuff like that. And another example of actual intervention delivery on a website front, you have Wix, Squarespace, or WordPress. I think this is what you guys use to develop your online.
We actually use like separate with coding, like a separate website, but there's some Wix integrated.
Yeah. Okay. So for websites, it's usually yeah, you have Wix, Squarespace. So there are a lot of in the web space, but not in the mobile space, right? So essentially, we want to build something like with RedCap, you know, get together with Bubble, which is a no-code app development. If they got together, had a baby, that's what we want to essentially create. You know, we want to create something like that. So as I said, there are limitations associated with all these existing platforms out there. So on the highlighted ones here, so these guys, they are intervention used for delivering behavior intervention, and these guys right here are for RedCap, SurveyMonkey, XDevelop, they're designed for collecting EMA data. But you can see that there's some limitations because most of these platforms, they're almost treating it like 2 separate things. Like you do your EMA study, great, but then you can't really do JEDI studies. So like there's nothing to talk to each other. So you need an integrated database stack. There are some platforms out there, but they're not exactly, I would say, user friendly. So with what we are trying to do is we're trying to make sure to fill out these gaps. We want to make sure it's a native app, so that's available on both Android and iOS. We want to make sure that it could integrate wearable data download, because I think that's a very powerful tool if you want to measure behavior. And then we want to make sure that you can really deliver interactive multimedia. I see that you guys have a very nice, like, I guess, media room setup. You can like film yourselves, and so you want to make sure you can deliver these multimedia, and then you can deliver them using advanced logic, right? So you can set advanced logic behind the scene. And then also one of the biggest problem right now is once you run out of funding, the app is essentially gone, right? So there's going to be no maintenance required. So we're trying to solve all this issue when we're trying to develop this tool. So this is where we put in some resources in 2020 to develop this platform. We have 3 goals. So one is we're trying to make sure that anyone that comes to this platform, they can develop any type of EMA studies, any type of apps that's here for education, any type of JEDI interventions. And now we're recently getting into micro randomization trials. I know some of you guys doing that, but that's maybe another conversation. But that's the stage that comes after JEDI. And then the second goals that we have is we want to make this free for students and researchers on a small scale. So anytime you're doing pilot study, it should be completely free and support multiple languages and so forth. And then the last part we're working on right now is we want to make sure that all the apps that you create on this, you will stay within the Pathverse universe. So then it becomes a repository. So then when you go publish your data or publish your article, they can refer to that. And you can save there, and you can also share your app with other people as well. So that's kind of the vision then when we created this Pathverse platform. So we started our journey in 2020, the pandemic. We're like, well, let's go all in. I think that the world's changing. So then we developed the platform in about 2 years period. And then we officially kind of worked with our university's entrepreneurship office to spin this off as its own entity. As a researcher spinning something off from the research lab, that's quite an interesting journey. I mean, we can talk about that a little bit later if you're interested about the journey. But the reason we did that is making sure that it could be sustainable on its own long term. So how do we develop this? So first is we want to understand what are some of the key features we need to be able to deliver the BCTs, all the BCTs listed in the literature. So within behavior health intervention, Susan Michi, you may know her, but she has a list of behavior change techniques. And then we want to make sure that we can map all majority of these BCTs onto the features we're developing. So for example, customized multimedia content delivery. So then you should be able to provide information based on behavior, goal setting, various different types of goal setting, form, act as a social support, notifications, surveys, self-monitoring, so forth. So that's kind of how we decided what type of features we want to implement. And then we try to figure out, well, how do you get researchers to create these mobile apps? So that first we have a research portal, which is on the web. So researchers who will use it create the intervention on the web, and then they can deploy multiple apps within the Pathverse app itself. The reason we picked the name Pathverse is there's different path within the universe. So we combine 2 words. So Pathverse, you can think of it as a super app your participants will download. Once they download, once you link the IDs, then they should be able to see your program. And that's how it works behind the scene. So here's an example of the UI, which I can show you guys a little bit later on the computer. But the whole idea is should be drag and drop, point and click to make essentially a mobile app. And it should be very easy to kind of implement questionnaires and download data and so forth. And then we want to make sure that it will be very user-friendly on the participant end of things, and it's very customizable. So you can customize the theme, the color, and then the various different types of self-monitoring tools and content. So that's an example of what it looks like on the mobile app side of things. And then how do you actually create an app? So we made it into kind of almost like a framework. So you set your program, And within your program, you have different lessons. You can think of like, you know, if you're delivering a course, there's like 10 lessons, you deliver that per week. And then you would then make each individual cards within the lesson. So the cards can consist of self-monitoring tools, video, surveys, so you can really mix and match. And then with the Jedi features, our first iteration of this is essentially you can then list the tailoring variables you want, whether that's based on questionnaires or steps for now. And then you can set your condition that's greater than or equal to, and then you can then deliver it. So this is our full list of our kind of features now. The feature list is continually growing, which is really, really great. We've been working with researchers around the world trying to basically meet everyone's needs along the way. And we're learning a lot through this process as well. So I think we can probably, Pathways right now can cover all these features, which we're really, really proud of. Okay, so here's what an example of what the app will look like. So this is an example app. So on the bottom, you have the content and you have your trackers. So trackers, you can then sync with your Apple Watch or Google Health. And then you can implement various different types of trackers that you want. It could be customized into self-report data as well, but for behavior researchers, like my physical activity researchers, this is very easy. We also implemented with, if you're doing EMA studies, literally we'll just have one giant sync button, because then you won't be able to see your data. So then, which is a good thing, you don't want to influence the participants' behavior if you're collecting data. Sometimes when they see how many steps they're walking, they will try to like gradually increase their steps. And then we have customized logging as well. So you can like, you know, log the exercise you're doing, but then this exercise logging could be used for other types of logging as well. So you can customize that along the way. So this is the type of exercise you're doing. So HIIT exercise versus the MS to monitor intensity continuous exercise. And then we also have goal settings. So the goal settings could be either set by the participants, or you can have goal settings that are set by the researchers. So they pre-existing goal setting. And you can actually attach point systems behind the scene. So there's an element of gamification if you really want it, which is kind of neat along the way. And then one of the other new addition feature we have is the community forum. So then people can go in and talk to each other, form a sense of community if you want it. So one of the really cool things is like you can pick and choose which features you want depending on your intervention. So that's so flexible. So if you just want to collect data, you can eliminate all the rest and just have a data collection page. Or if you just want to have a community forum, you want to use this as a chat feature, sure, you can just do that. So depending on what you need. And then, yeah, so there are a lot of other options behind the scene. Okay, any questions so far? Okay, I can show you what it looks like on the participant and researcher end of things on the web itself. If we can switch over the screen to, yeah, okay, perfect. Okay, so this is what the participants, so the researcher will see. So on the top here, so when you log in, so these are your studies, essentially. So right now in my account, I have 3 different studies. So once you log into a particular study, this is where the customization comes in. So we were looking at self-monitoring tools earlier. So these are all the self-monitoring tools you can have. You can just kind of flick them on and off, depending whether you want to collect the data or not, and it will then show up on the app. So it makes it really easy for researchers that way. But when you're creating a content, as I said earlier, so these are various different modules, and these modules can be moved up and down. So, and then when you edit a particular module, you can then kind of you see a live preview of what your app looks like, which makes it really easy for researchers to use. And then the last thing is, I think as a researcher, we love analytics. So we have all the analytics you want. We actually found, so I realized that like we're almost getting raw, like too raw to take the data. Like we're getting milliseconds of people on per page. And so there's a lot of post-processing. So we're actually building really interesting data dashboard at the end. So it's a little bit more filtered. So it's easier for researchers to process the data. Yeah, so this is what the platform looks like behind the scene. Yeah, so you can just, if you're interested in using it, you can just log into the website and just sign up and then just use it. Any questions? Yeah.
Is it all abstract physical activity or can you?
Ah, such a good question. Okay. Thank you for the transition. So I'm going to bring it to my next slide. Can you swap back? Yep. Yeah, thank you. So we designed this obviously with physical activity in mind as the first use case because we're physical activity researchers. But what we have done now is once it's been a year and a half now, we open it up to other researchers around the world. Right now we have over 150 researchers signed up. And then we're slowly seeing different use cases coming out. So I'm trying to go to the next slide. Okay. So here are some of the other use cases. So we have the executive function, physical activity, hypertension prevention, pain management, diabetes prevention. So we have some EMA studies coming out, and then we have some other types of studies coming out, which is useful. So basically, we're finding that this platform can be used for any type of data collection using mobile phones. Yeah, like self-report data essentially, because there's a survey feature just like Qualtrics. And then you can actually set quite sophisticated survey logics. For example, you can randomly have a survey show up between 8 to 12 p.m. And then you can also set it so that it will disappear or not disappear by the end of the day. You can also set it based on event trigger. So if your physical activity level is low, you can set a trigger. And then now we're also setting with GPS weather data. So another researcher requests if we can pull weather data depending on implement survey depending on weather data. So there are a lot of other use cases. Are you thinking of different use cases for you? Or?
Yeah, we also do some research to physical activity. That's not my main focus. So just in general, would be interesting to students rate teachers rate themselves for athletes, for example. Training on approach.
Yeah, absolutely. Yeah, so that's definitely going to use. So it's great in the use cases like you can do longitudinal assessments. It's a great use case for that. Yeah.
Is it also useful for time and motion studies?
So give an example of that.
For example, with nursing students that someone like an observer follows them around with all they're interacting a lot with patients or like interacting a lot with doctors. Right now they're doing this like administering medicine or something like that, and like logging what they do during the day and trying to make them more effective. Like
sure, yeah, you can definitely design this just as a logging app. So essentially you just have one module. You have one module just as a survey. So they just keep accessing that module to basically enter data. That's one way of using it. Yeah. Or you can build a customized tracker behind the scenes as well. Yeah. Yeah. So a lot of different use cases, I think, which we can eventually play around with. Yeah. Any other questions?
Can it provide feedback, for example, to other users, or is it like, for example, I'm thinking, for example, if your students would provide feedback about the class, and the teacher and someone see this, or is
Oh, okay, that's an interesting use case. So basically you want to have a survey, and then after all the students complete the survey, you want the teachers to see the survey respond. Yeah, technically it's possible because you're collecting the data, you know, so you can make that card, right? That special card. Yeah, so how we work is like, let's say if a researcher comes to, they're like, we wanted that particular feature, so we just build that particular feature into the app, which will be way cheaper than developing the whole thing from scratch, because then you have access to all the other features. So we just tweak that a little bit. Essentially,
you could potentially do that on the map. We say, oh, we have this budget.
Yeah, exactly. So then we just do that open. Usually our turnaround is like a couple months. We're working with researchers because the features. I think we're finally reaching to a point where the feature requests are like we have, I would say 80% maybe the features. So something like that should be too difficult.
Also related to the tool, we use in our online tool, we use of videos and the teachers would videotape themselves and then they would upload it to the tool. Is it also possible in the platform that they can like upload their own video or maybe even share their video with other teachers or?
Yeah, so currently no, but that could be
Okay.
integrated. Yeah, you can upload, essentially, we can upload text right now. And uploading video shouldn't be too difficult to do. Yeah. Yeah.
Because teachers say that it was difficult to videotape, but maybe you can just videotape it with just a small portion of their phone and it needs to be uploaded. It would be easier than what it is now. So that's why I was wondering.
Yeah, definitely, it's possible from that perspective. It's from a technology perspective, now we have set up infrastructure, so it's quite easy to implement that. Just that, I think the tricky part is like, you know, how long is the video, there's file size
Yeah.
and things, video files, bigger videos, so, yeah, so it's.
How adaptable is the user interface? So you mentioned the code design aspect. You said
Yeah.
everybody moves this, and there were some elements that needed to be tweaked.
Yeah, so, maybe I can go back to that slide. This is a really good question. So how the UI will work is that, the framework will be based on lessons right now, so modules. So you always have these modules, on the home screen. And then, so everything's grouped around these modules. But you can make the modules, the module doesn't need to be delivered linear, right? It could be delivered based on certain conditions that are met. So that's kind of our current framework for this platform. But we're coming out with new template designs. So we're trying to figure out, maybe you guys are interested in this as well, like what are the two ways of delivering information through a mobile app? So the way that we designed it, I think it's very almost like online course type of thing. We group them into modules, like cards, and we present every single week different modules. I'm sure there are other ways to present the data itself. So I always look at the TED Talk app, how they're organizing it structurally is very different from ours, but the way they organize the information is different. So we're trying to figure out like what are the different templates that we can have behind the scene that will meet the needs of different users.
Fascinating. Thank you for the presentation. Would you be able to say a bit more about the analytics that go into the decisions or delivering a Jedi intervention? You
Yeah.
mentioned decision trees, but
Yeah.
there's got to be more than just the decisions tree, I suspect.
Yeah. So on version 1, the reason that we picked that particular kind of branch of trees, one is we want to make sure that it follows the spirit of the framework that we're using for people in different layers. So that's the reason that we designed that particular order. But on behind the scene, we also have different versions of the tree itself. So you can tweak the tree depending on your kind of tailoring variable behind the scene. So all the trees that we have designed right now are what we call static, in the sense that they are, you can think of as if and else statement. They are not updating it by themselves, depending on the performance. So that's our next version of it. So how do you implement a customized algorithm behind the scene? So depending on performance, then you will just automatically update it.
It's actually not using the data from the user that picture at the moment.
So it's using the data, that's generated by the user to deliver customized content. But then it's not, so from that perspective. But it's not in the sense that analyzing the data on the fly. So the tree is static. Yeah. So we would argue that this is like version 1 of the Jedi. I think the next version, this is why you have like machine learning algorithm behind the scene that will constantly adapt behind the scene. But I think for us, this is making sure that can this generalized framework work for version 1 of the Jedi, and then we are working on machine learning algorithm.
A related question, so this is individual tailoring, this is data from one person analyzed behind the scene, it's static or dynamic.
Yeah, so it's within person, yes, so
It's always
you're,
within person, so the question was, do you also, as a researcher,
Yeah.
do you also do aggregated kind of analytics and have them to be integrated and form some of your decisions?
yeah, so that's our next step. Yeah, so we're trying to figure out, I mean, the way that we design the tree is very based on kind of the theoretical framework. So we know that if you're not providing support, and this is probably based on the theoretical framework, then we should work on kind of your active attitude, things like that. But hopefully in the future, we'll be able to use aggregated data as well as within person data to build additional algorithms behind the scenes. For example, based on usage data, right? I think that would be very interesting tailoring, or based on person's demographic data. Based on, yeah. So those are some of the things that we're working out behind the scene. But building the infrastructure, but also figuring out the algorithm behind the scene, it's yeah. So I guess version 1 is if else static algorithm, and then version 2 we're working out dynamic. Thank you.
So, regarding the security of the data, currently there, you said hundreds of researchers already using it. You guys also have access to the data that they collect, or how does it?
Yeah, we don't own any of the data, or we don't, it's not our privacy policy. We don't own data, we don't own the content, researchers create, researchers own that, no, we just own the underlying technology provided. In terms of where the data is sitting, so in North America, it's either sitting in Canada, this is where we're based. And then we're working now, we have a paid version where we can put the data in the person's home country. Yeah, so according to GDPR, for example, or like if in Australia, we can move the data to Australia using, so we're working with AWS, Amazon Web Services, so that we can just put it over. But we are hit up compliance, so in North America, we're mostly targeting right now. But we're looking to find new use cases. For example, like the dynamic tailoring, we would love to work on that. But it's just sometimes we have limited manpower and human resources and funding to make it on.
Two quite different questions. One, does your app have the capability of storing data so that the feedback they can give them this progress over time, as well as what they're doing right now?
Yes, of course. Yeah.
Yeah.
So it's always doing that. So we have the option of storing the data locally on the phone itself, or storing it being back to the cloud, and then we have an analytic engine behind us to analyze it and spit back whatever content you want to show based on that data.
I guess the other things, I'm impressed with your generosity of developing an app for the world to use for relatively free. I was surprised that your university is happy for you to do that, because obviously this is something that they could commercialize, and it's the commercialization of this app through your university, whatever commercial arms. Is that something that's going to happen in the future?
No. So
Okay.
the short answer is no, because we negotiated a deal with them. So we're all the Pathverse Inc. owns all the IP. And then obviously there are royalties paid back to our university, very small royalty, and they have a very small stake. So
That's a balancing act.
yeah, so we're on a freemium model.
Yeah.
I think, right? Like we have the base, we truly believe, like, in order to progress the field forward, you need to have these tools accessible free. And then you can do pilot studies. And we're hoping once you do your pilot studies, you'll write grants, do more studies, and then you write ourselves in. So then we then build on the next.
Well, that's great for building your track record. But I guess also lots of people that are going to use the apps, hire you as consultants, and then you can bring in some monies that will help you develop the program further.
Sure. Yeah. I mean, if they want to do that, yeah. But I think it would be great if they don't hire me as a consultant, just pay the programmers to develop new features. That would be great as well. Yeah. But our annual fee, like even the paid version, so we support, it's about works out to be about like $300 a month, $400. So it's pretty reasonable, I think, for a lot of research companies.
But I suspect in terms of building your track record, you're much better off giving it away, because then you'll develop a contact based all over the world. And
Yeah.
I have dozens of
know,
collaborations.
Yeah,
Yeah.
the thing I find most rewarding is like to find out like, oh, some students or like where to do their EMA study and they publish a paper and they cited us and like, oh, that feels so good. Like far as that's, and then I think gets the programming team excited about because they realize they're helping other people as well. And then the tools we're developing, I mean, from the technology perspective, we are using existing technology and we're just rewriting code, making it presentable for researchers.
Behavior change is very difficult. It's very difficult to change behavior. And I'm wondering if an app can do that.
Yeah, I'm glad you asked that question.
So the study you presented, it was a pre-post. It didn't have a control group. And just how much confidence do you have that these 150 researchers putting apps on the phone, changing people's behavior, they can produce using a rigorous design?
Yeah. Very good question. So the study we put is a feasibility trial. So like we follow this something called orbit model. So then first you do feasibility to find out if the intervention is acceptable or not before we move to effectiveness and larger trials. So this is very much early on. But we do have other trials that are going on right now. There are randomized control trials there where we implement mobile health virtual delivery versus control. And then based on the systematic reviews in the past and some study done in the past, the short answer is yes, it's possible to change people's behavior, but there are a lot of challenges associated from engagement, from usability, because once you have one bad UI user experience, most people want to use it. It's dependent on person's health literacy, computer literacy, income. There's still a bunch of factors. But generally, I mean, changing behavior, you probably need to apply like the ecologic model of health, where you change the policy, change from a system level all the way down to the individual level. But where I see mobile apps come in is one of the tools in the toolbox, right? So what we're actually finding a lot with the population group we are working with is a hybrid design. So meaning that you are not solely dependent on the app, but app becomes a part of the solution of in-person delivery. We find that works the best in a lot of the use cases, because when you give the app itself, the engagement data goes like this. It's not like 4 weeks you have, and then you end with like 20% users. Maybe you can bump it up a little bit with like, we have incentives, we had Jedi, we have like check-ins, like maybe we can bump it up, but it's still, it's like, falling over time.
I think one of the basic problems would be, if I go into a family, and I bring my app and we're gonna change PA, and the app's gonna have these built-in features, like those settings, self-regulation. It's kind of cart before the horse. What would really work is I want to change my behavior, and I'm looking for an app that would assist me in the self-regulation goals. That I already want the behavior change motivation already occurred. Now I get access to the app. But to create the motivation within the app. Well, remember, these are people that are volunteering to be in this program, so they are already
motivated. That's why I think
that's why.
So this is why when we're looking at the baseline data that we have, like the initial layer of intention to change behavior is actually really high. They're all like scoring 5, 6, so which means they're like having the intention to do it. By the time people download the app from the App Store, they already have somewhat of an intention to do it. And with physical activity, I think most people know physical activity is good.
And that could be why you didn't have the change in the attitude as well.
Yeah, exactly. Yeah. So this is why the intention behavior gap is so. Most times we have the intention to go exercise on a daily basis, but from an execution perspective, we don't execute it. So it's about 50%. It's about 50% of the people you have the intention to actually execute. That's like flip of one, right? So
your 80% participation, follow through. That's higher than you would normally expect. So you had
they're good.
You had a motivated group. Maybe because your app was so good, but it may also have been
very motivated.
And then what you really want to know is what that percentage is 6 months later.
Yeah. So with the feasibility study, yes, that's definitely
sure.
But another goal we had is just simply make the infrastructure technology work behind the scenes as well. So we have like 2 teams going. So it's even though it's a small scale study, fast paced, but So now we're working on the next version of the app itself, but we realized how important is to actually integrate some human aspect into it as well. So we're probably going to keep like a bi-weekly Zoom session delivered virtually that mimics our actually community program. So we have another community program. It's called Generation Health. It's a similar concept, but we have
And you say this is a 10-week program, but there's no real time limit.
there's no real time limit.
Yeah.
Yeah. So
So
theoretically,
people can continue using the app indefinitely, and that's what you want.
yeah, and then, but we don't have new content generated after 10 weeks. So this is where I think ChatGPT could be interesting. And you can continuously generate, because right now it's a lot of work behind the scene with lots of scenarios, if statements, if they're manual, labor intensive. So, yeah, and I think tailoring algorithms still could be smarter.
So I love the idea of the Jedi interventions. I think that's research catching up with tech companies that have been doing this for decades. I wonder, can you talk about the challenges of evaluating the Jedi intervention? Because, you know, there's a little bit of a risk to internal validity that each participant receives a different intervention. And then if we change something in the decision tree, or if we're using the machine learning model, that's going to adapt over time. That means that each person potentially receives a different intervention. I know that's not necessarily a problem for me, because we want the most effective thing, but it does make it challenging to evaluate. I wonder if, like, have you?
Yeah.
Yeah.
So this is where the micro randomization comes in, right? Micro randomization trials. So usually randomization will occur on group level, right? Control intervention. Micro randomization, you're randomizing within person at a decision point. So at that particular decision point, let's say, you are presented with the opportunity to give, a positive message or a negative message. So then you will randomize at that decision point within person, and you'll figure out over time what that actually work. Is a positive message that's better or negative message is better? And then you can compare that within the person, but also across group as well.
Like A/B testing.
A/B testing. But so the really neat thing about micro randomization is you need less sample size. Because then you are using yourself as the comparison over time. So that is how you evaluate Jedi, truly. That's one way. And the second is you deliver the Jedi content right away, and then you are then figuring out afterwards how long do you actually see the change of physical activity. So then that gets into like EMA assessments. Your EMA assessment needs to be so good to the point where you can actually see these changes over time. So the immediate response. So those are the two ways you can really evaluate that. We're not that great at it, to be honest. So we're working right now. This is very true, like pre-post. Really, if I want to do this again, we would measure, randomization, or we're looking at immediately after the prompt. The next day, what would be the child's physical activity level? So we do actually have that data. We just give it.
That's really limited as to what the outcomes that you're going to be measuring using that within-person randomization, because you will typically have diffusion kind of effects, carryover effect that would complicate that immensely.
Yeah, it can be, I guess. Yeah. So maybe it's perhaps like, I also saw like adaptive trial design as well. That could be like another way to measure this. Yeah.
Okay.
You mentioned that you had some other large trials underway. What do the control groups look like in these things?
Yeah, so the other trials, we're comparing, it's a 1 year intervention, 1 year follow-up. The intervention is about 12 weeks, and then follow baseline 12 weeks, 6 months, 12 months. So control group, they just get a standardized website. Yeah. So standardized web intervention with content that is developed by like the Canada's food guide, for example, or like resources you can already find online.
So just sort of information.
Yeah.
Rather than anything that's specific to them.
Yeah, exactly. So publicly available intervention that are.
Control groups used to give out brochures, so like brochure.
Yeah, but we put it on the web.
All right. Well, thank you very much, Sam, and thank you to the audience. So please give a round of applause. Thanks, everyone online.
Yeah, I'll be around if you guys want to, have questions or just want to, yeah,